Hey there, today let's try to solve this problem called can't substring divisible by last getter. So basically in this problem, we are given string s containing only digits, so it's only numbers, but it's a string, and we need to return the number of substring of s that is divisible by their non-zero last digit. For example, in this string s, there is a substring of 1, 2, a substring of 1, 2 here, and then this substring in particular is ending at the digit 2, and 12 mod 2 is equal to 0. Because this is an even number. There are 11 number of substring can fulfill such requirement. That's why we are returning 11. And let's see how can we actually reason out of a solution. There are mainly two observations to solve problem. The first observation is that if you look at this example, you can see 1, 2, 3, 4, 5 mod x for any digit minus 1, 2, and then 3, 0 mod x will be equal to 3, 4, 5 mod x. So basically it's here. And for the example, 1, 2, 3, 4, 5 mod x minus 1, 2, 3 mod 1, 2, 3, 0, 0 mod x will actually equals to 45. So what I'm trying to say is that if we keep track of all the, for example, s equals to 1, 2, 3, 4, 5, and we look at the digits from left to right, and each time we keep track of 1, 0, 0, 0, and also 1, 2, 0, 0, and then also 1, 2, 3, 0, all of them mod x, of course. And in theory, we can know any substring that is ending at the current digit if we have keep track of that information. And one trick here is that for every time 1, 2 mod x, if we move one number or one digit to the right, it means 1, 2 will become 1, 2, 0 in the next round. So that's actually easy to do that because x will only be a limited set of numbers. So what we can do is basically for every number modulo x, and we times 10 and then modulo x again, and this will move to this new remainder, and we do that for every x, and this x will only be 1 to 9, so it's not a very huge computation. That's the first observation. So the second observation is that if you look closely, you would realize the result for 2 is not actually relevant to the result ending of 3. So what I'm trying to say is that instead of trying to calculate all the answers at once, we can create a helper function called count dig, where this dig will be 1, 9, 1 through 9, and each time we only focus on this particular digit, and we will return subarray count that ends and also divisible by this digit. In that way, we don't have to go through the hassle of keeping track all 9 different remainders as we go along this string. We only need to keep track of one modular, which makes things so much easier. And with that, I think we have enough information to code the solution. First, we initialize n set to 0, and then we declare n as the size of the string, and then we create this helper function count we mentioned before. Count will only consider digit dig, so we only keep track of the modular of dig, which will be 1 through 9, and they will be executed separately on this helper method. And first we keep track of m, which this will stand for the current modular, and this mux will have a size of 10, and each value in the factor represent how many subarray or prefix are there that we can match with. So the first thing we need to do is to initialize mux 0 to 1, because if the whole prefix is modular by the current digit, it means that we can use the whole prefix as the answer. So that's why initially we have to initialize 0, mux 0 as 1, and the current result we initialize that at 0, and then we can go through the string from left to right, and each time we extract the digit from the string, and then we update our modular because we have times 10 there, and then have to modular that by dig, which is the current digit. And if the current digit happens to be the digit that we are calculating right now, and we have to add the number that ends with the same modular. So because we have a prefix of modular 2, for example, and then we are currently having a modular 2 as well, so 2 minus 2 will have a modular of 0, so modular of 0 means that is divisible by dig. That's why we have to result plus equals to modular of m, and the number of prefix that have the modular of m. And after doing that, we have to consider the current modular to the frequency as well, and then we have to consider the next modular, because as I mentioned, the prefix will go from, for example, 1, 2 to 1, 2, 0, and then 1 to 1, 0, and so on and so forth. That's what we're trying to do here. So for the 0, we have to do a special thing for it, because 0 times 10 mod the dig will become 0 again, so we don't have to do anything. So the next modular modulo of 0 will directly inherit from the modulo of 0. And then for any other digit, the current digit j will become j times 10 modulo dig. And then we have to do that for every digit here. We have to use plus equal there instead of directly assign, because some j might happen to have the same next modulo remainder, so we don't want to use assign because that would lose one of the assignment there. And then after doing all of that, we assign mux to the next mux, and then we return result for this helper method. And then as we mentioned, we have to do the digit from 1 through 9 for all count, and then we can return the answer after that. Let's try to run this. Okay, accepted. Let's talk about the time and space complexity. For the time complexity, it will be O(n), mainly because we go through the string like 10 times. So in theory, it is 10 times. And since 10 is constant, so it's only O(n). And for the space complexity, it is O(1), because we haven't used any extra space for that. The only extra space that we use is from here. But 10 is also a constant, so it's only O(1). So yeah, that's a pretty efficient solution. And thank you so much for watching, and I'll see you next time. Bye bye.